So at the beginning of this second part of the video, we're going to do the cosine graph, so you should be going to the next slide that we just finished off at. So I want to show you how a cosine graph looks different, and one of the things that you should notice almost right away is that the graphs look almost identical. There's only a couple of slight differences. The same thing follows with the cosine graph. We have y equals a regular cosine of x. The amplitude is still 1. The period is still 2 pi over 1, which is just 2 pi. And the reason is because there's a 1 in front of the x. Even though you don't see it, it's still a 1 in front of the x. So now the difference is we still want to, we're going to graph our unit circle. We have all of our points. We just talked about 1, 0, 0, 1, negative 1, 0, 0, negative 1, and then all of the points that we are around. So this is 2 pi, 3 pi over 2, pi, pi halves, and then 0 to start. So the idea of this is the same thing. It's just now the cosines are going to be the x values. So if we plot this as 1 and we plot this as negative 1, you should see that our cosine is always going to start at 1 as long as it's a general cosine. And we still want to break our period up into 4 basic quadrants. So our first one is pi halves, our next one is pi, our next one is 3 pi over 2, and our next one is 2 pi. And again, now that we're starting here, we go up 2 pi halves and we're at 0. And we go down, we go over to pi and we're down at negative 1. Go to 3 pi over 2, we're back to 0. And then at 2 pi, we're back to 1, which is where we started. And as you can see, the general shape of the graph looks exactly the same, as long as I know how to draw correctly, and as long as the computer does not mess up. But the idea of this is that it's going to be the same type of graph, it's just shifted a little bit left or right. Okay, so those are your basic sine and basic cosine. You need to know those. It's not about, you shouldn't have to draw this out every single time. You should know that the basic sine graph starts at 0, and you should know the basic cosine graph starts at 1, and you should be able to break these up into quadrants and knowing if it's at 0, 1, then at pi halves it's going to be 0. And then it's going to go down to negative 1 at pi. And basically you're just going around to these major points of your unit circle over and over and over again. Now when we get into different functions like this is where it gets to be a little bit different, because now we're changing it just slightly. So this one's a basic example. The amplitude here is 4. How do we know that? Well, the 4 is out in front. The period is not changing from what we just did. This will still be 2 pi divided by 1, which is equal to 2 pi. So what does that mean? It means that we're going to essentially do the same thing. We're going to put our coordinates in. Now, the only difference is because our amplitude is 4, we know that a sine graph is still going to start at 0. As long as there's no shifting, which is what we're going to get into the day after we do this, we know that it's going to start at 0. The difference is everything about this graph would be exactly the same. The period is still the same. So because the period is still the same, we're going from pi halves to pi to 3 pi over 2 to 2 pi. The only thing that's different is now that our amplitude is 4, instead of us going up to 1, we are now going to go all the way up to 4 and all the way down to negative 4. So our first point that we go to, because our sine graph goes up to 1 after pi halves, because the amplitude is 4, it'd be 1 times 4, so it's now 4. It'll come back to 0 at pi. It'll go down to negative 4 at 3 pi over 2 and back to 0 at 2 pi. And again, the graph looks almost identical. It just has a different amplitude. But it looks the same. Just is a little bit higher and a little bit lower. And actually it looks almost exactly like what we just graphed. We just made the intervals a little bit smaller. So that's how you change a graph for the amplitude. But as you notice, the same thing is done. We're breaking it up into 4 equal parts based on what our period is, and then we just go up to our amplitude and go down back to 0, down to our negative amplitude, and then back to 0. So those ones should be pretty easy when the period doesn't change. Where it gets complicated is the next one, where the actual frequency in our period is affected. So first, again, we want to identify our major things of our graph. So our amplitude here is 1/2 because there's 1/2 in front. Now our period is going to be different because we actually have a value in front of our x. So if our period is going to be 2 pi divided by b, then it's going to be, in this case, 2 pi divided by 2 pi is equal to 1. So when I go through and I try to graph, it's going to be the same concept. But now, what we're going to do is, when we actually try to when we do our intervals are not going to be pi halves, pi, 3 pi over 2, and 2 pi anymore. What they're going to be is, we know that our very last point has to be 1, because that's going to be where the period of the graph ends. Okay? So the idea of this then is, we need to make sure that we are graphing 4 equal intervals. So what would 4 equal intervals be from 1? Well, I know that halfway between is going to be 0.5 or 1/2. Halfway between there is going to be 0.25 or 1/4. And then halfway between 0.5 and 1 is going to be 0.75. So that's what we need to be aware of, is making sure that we can break our interval or break our period up into 4 equal intervals. So when we go through and graph this, we still use the same philosophy. If I say that this is 1 right here, and this is -1 down here, we clearly have to know where 1/2 is and where -1/2 is, because that's what our amplitude is. But again, we want to make sure we're starting at the right place. We're not starting at 1 anymore. We're going to start where the amplitude is. So we're starting at 1/2. But notice, now that we have everything done in quadrants, this is really easy, because now we go down to 0 as our first move. Our second move is down to -1/2. Our third move is to go back up to 0. And our last move is to go back up to +1/2. So we have a cyclical curve, but it just looks a little bit shallower because of where it's at. But notice the graph looks exactly the same. We've just labeled it a little bit differently. If our period was 4, then it would be 1, 2, 3, 4. If our period is 2, it's going to be 0.51, 1.52. If our period is 4 pi, it's going to be 1 pi, 2 pi, 3 pi, 4 pi. Basically, whatever we get for our period, if we want to draw a full cycle of our graph, we just need to break our period up into 4 equal parts, and we know where those major parts are going to be, because even though we are familiar with our unit circle looking like this, and this being pi halves, what we're really doing is we know what the very first point is going to be, that what's changing it is what's in front of the x and what's out in front. So even though it says it's pi halves, our first major point is going to be 1/4 of what our period is. Because if we were to plug pi halves in for x, it would give us exactly what we were looking for. So if you understand taking your period and breaking it up into equal 4 parts, it's going to make things a whole lot easier. Okay, so this is all for the basic graphing, and I know there's probably some confusion, especially with what we just got done talking about, but we're going to work on this in class. And hopefully we're going to get through it, without a huge issue. So I will see you guys in class, and make sure you guys ask the questions of things that you're not sure about.